This is Where We Live. I'm Lucy Nalpathanchel. A Pew survey measuring American opinions on genetically modified food found nearly 40% worry GMOs are dangerous to their health. The same amount have concerns about how genetically engineered crops are impacting the environment. Today, we tackle the GMO question. Scientists will join us to explain exactly what a GMO is and whether mainstream concerns are warranted. Now, do you look at labels at the grocery store to see whether there's a GMO ingredient? Does that affect what you buy or eat? Join the conversation, 860-275-7266. You can email us, wherewelive@WNPR.org, and you can find us on Facebook and Twitter at Where We Live. First, what exactly is a GMO? Joining us from a studio at Cornell University is Dr. Margaret Smith, professor of plant breeding and genetics at Cornell University's School of Agriculture and Life Sciences. She specializes in corn breeding, and she also works with New York State farmers through Cornell's extension program. Margaret, welcome to the show.
Thank you so much. It's a pleasure to be here.
So I started off by asking about GMOs, what exactly they are. So when we look at the acronym, genetically modified organism, can you break it down for us when we hear or see that in articles or maybe on the food that we're buying?
Yeah, I'll do my best on that one. So you'll notice as I talk that I always talk about genetically engineered organisms. That's the same in my parlance as what most people would call GMOs. And there's a reason for that I won't go into right now. But genetic engineering is the latest in a whole series of ways humans have tinkered with the genetics of the crops and the animals that form our food system. It's a tool that takes advantage of the ability to add one or a few genes or change one or a few genes in a crop without necessarily the need to cross-pollinate them or be able to find that gene in another variety of the crop that already exists. So it's a new tool in what has been a profound history of tinkering with the genetics of the crops we use for our food system.
Now, you mentioned that you don't like the term genetically modified. Explain why that is.
I had a feeling we were going to come back to that. And it has to do with exactly what I just said. Humans have been modifying the genetics of the crops we use as food ever since domestication, which is something that happened 7,000 to 9,000 years ago. The earliest agriculturalists chose which variants, naturally occurring variants, were most useful to them in terms of providing food, and they saved the seed of those. And that had the impact of gradually over time changing the genetic nature of those crops so that what we look at today as, for example, a head of broccoli bears almost no resemblance to its wild ancestor that it was originally domesticated from. So I don't like the GMO term because I think it really confuses the issue. The issue is not that we haven't genetically modified the things that are part of our food before. The issue is that this is a new way to do that. So let's focus on what we're really talking about, which is genetic engineering.
So I understand you're also a corn breeder who uses traditional breeding techniques rather than genetic engineering to select for crops with the traits you're looking for. So describe the difference about the traditional breeding techniques and how you're able to do that.
Okay, so my program is all based on conventional breeding. So what I do is I take corns that grow well here in New York and I cross them to other corns from anywhere around the world that might have traits that would be useful. So for example, I do breed corns that are more resistant to diseases. Sometimes those sources of disease resistance might come from tropical corns because they get a lot more disease pressure there. So then the corn has naturally evolved its own resistance to those diseases. So I'll make those crosses in my breeding nursery and then try to pick the individuals that have the combination of adaptation and yield potential here in New York and resistance to the disease. So that's the conventional breeding approach. The genetic engineering approach might say, okay, I haven't found a good source of resistance, but I see these genes in other species that I could use, that I could perhaps build into corn and make it therefore more disease resistant. So it reaches beyond the cross-compatible things I can actually cross-pollinate corn with to bring traits in from other species, or it goes into the corn genome itself and tinkers with the order of the genetic code to find options that might create more resistance. So it can get traits that I can't.
So when we're talking specifically about options to generate resistance, when we look at big ag today and the majority of crops grown in this country in the Midwest, those are examples of genetically engineered or modified crops that have resistance to specific bugs or even weeds?
Yeah, that's correct. So there are a lot of them that have been engineered for resistance to a variety of different insect pests. And I have to say that I've also worked a long time on insect resistance breeding in corn. The resistance you can get from those genetically engineered traits is higher than anything I've been able to come up with through conventional breeding. So it can be a very fast, effective, and highly effective way to control those insect pests. There's another large group, and probably the single largest group of genetically engineered crops across various different species, is engineered for resistance to some common weed killers, common herbicides, such that you can spray that weed killer over the crop. It will kill most other plants, but it won't kill the engineered crop. So it gives us additional options for controlling weeds that were not as simple previously.
And when we're looking at genetically modified crops, again, grown in the Midwest, many people have heard of Roundup Ready or genetically modified seeds. Can you talk about that?
Sure. So the Roundup Ready is a great example of what I just talked about, crops that have been engineered for resistance to an herbicide. Roundup is an herbicide that basically kills plants. It targets an enzyme system, a process that's found only in plants. So if you, what scientists did is they found naturally occurring bacteria that had the ability to break down the chemical that causes that damage to plants in Roundup. So if you take the gene from the bacteria that can break that chemical down, you build it into a plant like soybean or corn or cotton or canola. That plant is then able to break down the damaging chemical in the Roundup herbicide and therefore is not killed by it, whereas all the weeds around it do tend to get killed. So that's how that technology works.
And then when you mentioned insects, so again, allowing the plant to produce a protein that's toxic to insects, can you break that down for us as well?
Sure thing. Those ones are almost all based on a naturally occurring bacterium called Bacillus thuringiensis, or BT. BT is good enough for now. BT is a bacterium that's widely used still. It's been used for a long time as an organic and natural insecticide by spraying the bacteria on crops, plants, fields, things in your garden that are being attacked by insects. And then that bacteria is actually a disease of the insect. So when the insect's exposed to the bacterium, it becomes sick. Some proportion of them die. So for the BT or insect-resistant crops, what scientists did is they found in the genetic code of the bacteria the single piece of genetic material that codes for the protein that then, when it's ingested by an insect and inside the insect gut, is converted into something toxic. So it's important to realize that the protein itself is not toxic. Insect guts are alkaline. Our guts are acid. In an alkaline gut, a chemical reaction happens with that protein that makes it into a toxin. It basically makes holes in the insect's digestive system. And you can imagine if you had holes in your digestive system, it wouldn't really be very good for your health. You would die. So does the insect. So this is a handy system because the protein itself is not toxic. It's the fact that it's in that alkaline insect gut environment that causes it to be changed chemically into a molecule that's toxic to the insect. That's what makes them so, these proteins, so safe for humans and also for a number of the non-target insect species. So that's been built into the plant. Therefore, with each bite of the plant that the insect takes, it gets that protein. Once that protein enters its alkaline gut system, it's changed into a toxin and it kills the insect. So it's a highly effective means of getting insect control.
This is Where We Live. With us from a studio at Cornell University is Dr. Margaret Smith, professor of plant breeding and genetics, who specializes in corn breeding at Cornell University School of Ag and Life Sciences. We're talking with Margaret today because we're learning a little bit more about what exactly is a GMO, a genetically modified organism, and about some of the controversies surrounding when people think of GMOs and genetically modified crops. We wanted to find out more about whether some of those questions, those concerns are warranted warranted. Specifically, one that comes to mind, and I mentioned it earlier with a Pew survey of Americans. There are Americans who worry about whether eating genetically modified food, crops, or processed food that includes particular GMO, that is harmful to their health. What does science tell us?
Well, from my reading of the science so far, I don't see any evidence that the currently commercialized genetically engineered crops pose any risks as food or as feed. So there's been actually a lot of research done on that, and the consensus in the scientific world is very broad about that. I want to say right away, together with that statement, that doesn't mean that every other genetically engineered crop you could think about developing will be equally safe. This is one of those situations where we need to monitor and take these on a case-by-case basis to ensure that there isn't some unexpected food safety or feed safety issue, an unexpected allergen, any one of a number of other possible things that we need to monitor for and be vigilant about. So the first point is I think the scientific consensus is very solid and very broad that currently commercialized genetically engineered crops do not pose a food or a feed safety concern. The other thing I will say is that many of the ways in which these make their way into our food system is in very, very highly refined ingredients. So you've mentioned the Midwest, where there's a lot of corn and soybean grown, and even cotton. These are some of the sugar beet. These are some of the most widely used genetically engineered crops. Many of the ingredients we consume from those crops are highly refined ingredients like beet sugar or corn syrup or cornstarch or soy lecithin. Refining is a process of purifying. So by the time you've purified down to get soy lecithin, pretty much the only ingredient there is soy lecithin. There no longer is genetic material or DNA in that. There no longer is the protein that was produced by that new DNA. So the soy lecithin from a genetically engineered soybean is chemically identical to that from a non-genetically engineered soybean. So many of the ways, not all, but many of the ways these things make their way into our food system is through these highly refined ingredients that really retain no signature and no characteristics and no chemicals from the genetic engineering process. Now, if you're eating whole grains or whole foods, whole corn, things made from whole corn, things made from whole soybeans, then you would be able to find that protein still in there.
We're getting a tweet from a listener who writes, GMOs make it more likely that people in countries that experience famine will get fed. They can reduce agriculture's unsustainable use of water. Complaining about GMOs is a hashtag first world problem. We're going to get more into the consequences on the environment of big ag and a reliance on genetically modified crops in just a little bit. But I wanted to ask you, Margaret, one of the reasons we are also doing this show is because recently the USDA has proposed recommendations on how food should be labeled if they have been bioengineered or genetically engineered. I'm just curious what your thoughts are on that.
Yeah, that's a really good question. I was just looking last night in preparation for this at the Federal Register statement about that new disclosure standard, and they're in the process of getting comments on it. So for people who are concerned, this is a great time to be able to go and look at the things they're asking for input on. This was required a couple years ago with a law that passed in the federal government to say the USDA needed to develop a standard for labeling of what they've called bioengineered food. I think it's going to confuse people just a bit to add yet one more term to this whole debate, which is bioengineered, but that's what they've settled on, so we might as well go with it. And I believe that they're debating right now the issue I just talked about, which is where do those highly refined ingredients fall? Are they considered an ingredient from a bioengineered crop when there's no measurable difference in the bioengineered and the non-bioengineered version, or are they not? And that will have a big impact on what gets labeled and what doesn't. So when you look at the packaged and processed foods, the things that are in the center part of the grocery store, those are the ones where a lot of them might have ingredients from cotton or cottonseed oil, for example, soy, corn, sugar beet, and so on. So many of those ingredients are these highly refined ingredients. Should those be labeled, or will that just further confuse people? So I think they're trying to find a way to get those labels on the foods where it really matters, where there really is something measurably different. They're asking the question about whether it matters to people if those highly refined ingredients are also labeled, even though there's nothing you can measure that's different about them. And they are asking a number of other questions in that guidance. So I think it's a good time to look at it. I'll also just say that it does exempt a few things. It exempts things like restaurant foods, which would be very difficult to deal with. But they're really trying to comply with the general public concern about how, for those people who are concerned, how can we know whether a given product was produced from a genetically engineered crop or not?
You mentioned that this ag rule is in response to Congress's GMO food disclosure law in 2016, which effectively blocks states, including Connecticut and Vermont, from having their own laws of how they want to label foods and crops that involve the process of genetically being engineered or modified. And you mentioned also that this one of the options is using this BE acronym for bioengineered that most people may not have even encountered. It looks like they're avoiding the controversy and the questions that people have surrounding genetically modified organisms or GMOs.
Well, I think they're really trying to avoid some of the terms that have been so inflammatory. Bioengineered is a fine term. It's just a whole new one that all sorts of people are going to have to become familiar with understanding what it actually means. So it is frustrating to me that we have so many different terms in this because I think it really confuses the debate. It makes it hard for people to understand each other in terms of what are people concerned about? What are you concerned about? What am I concerned about? Are we even talking about the same thing? So I think it does rather confuse things, but it's a term that I believe we're sort of stuck with because of the legislation that passed.
This is Where We Live. I'm Lucy Nalpathanchel. Dr. Margaret Smith is with us from a studio at Cornell University in Ithaca as we talk about GMOs. After the break, we'll talk about the consequences of our nation's food system that relies on genetically modified seeds and crops. And we want to hear from you, too. You can join the conversation, 860-275-7266. Find us on Facebook and Twitter at Where We Live. This is Where We Live. I'm Lucy Nalpathanchel. We've been learning about GMOs today on the show and how genetic engineering to make a plant more resistant to pests that benefit big crops grown in the Midwest, crops like corn and soybeans that are used to make many of the processed foods on supermarket shelves today. Now, a majority of scientists say there's no evidence that GMOs are harmful to our health, but what about the impact on the environment? We're going to get to that in just a little bit. I wanted to go back to my first guest, Dr. Margaret Smith, professor of plant breeding and genetics at Cornell University. Dr. Smith, before we head forward into our conversation, if you could break down for us again when we're talking about these labels that might show up on food in supermarkets through this ag rule that might be coming down the line. When we're talking about labeling genetically engineered food, we're talking about the process they went through and not specifically an ingredient.
Yeah, that's exactly right. We have really two ways that we label things in grocery stores today. One is called product-based labeling, and those are the labels that all of us are familiar with that list percentage of iron and percentage of fiber, share of the required daily amount, the carbohydrates, the sugars, the fats, and so on. So those are about the contents of what's actually in the box or the can or the jar. The other kind of label we use is what's called a process-based label. And that label is the easiest example of that is the organic label. That's really not telling you about the contents of the ingredients, but rather about the way in which they were produced, right from the purchase of the seed on through the farming system, the processing system, and so on. So that's a good example of a process-based label. Most of our labeling is product-based. Almost everything has a product-based label on it, but we have increasing interest in some of these process-based labels. The bioengineered label sits somewhere in between. So for an ingredient like a whole papaya that might have been genetically engineered, the genetically engineered label does tell you something about a piece of DNA and a protein that's in that papaya that would not be in the non-genetically engineered papaya. For the refined ingredients we were talking about just before the break, things like soy lecithin or corn oil, the bioengineered label is really a process-based label if it's put on those ingredients. because the corn oil is just oil. It's not genetic material or DNA. It's not protein. It's just oil. And the corn oil, whether it came from a genetically engineered corn or a non-genetically engineered corn, is chemically the same. So then the bioengineered label becomes a process-based label. I think either way, it will give people who have any level of concerns the option to choose if they're concerned about the role these things play in our agricultural system rather than the ingredient itself or its safety. The process-based label may be one that's helpful to them. So I think to ease people's concerns, labeling may be a good idea. I'm just concerned that it may also just add confusion to everyone's impression because of all the new terms and new ways of providing that information.
I wanted to bring into our discussion now McKay Jenkins, a professor of English, journalism, and environmental humanities at the University of Delaware, also author of the book Food Fight, GMOs and the Future of the American Diet. McKay, welcome to Where We Live.
No, thanks for having me.
So we've been talking and learning that scientists, there's a consensus for the most part that there are no health risks to, consuming genetically modified crops or, again, the food that GMOs may be in. But we want to talk more about the consequences on the environment, and that's something that you have talked about and written about. Walk us through some of those concerns.
I will. I've actually been very interested in what Dr. Smith has been saying, and I agree with a lot of what she's been talking about. There's a lot of confusion out there, especially as you've talked about recently with the labeling. But my point is that the confusion about food goes way deeper than just this question about what term we're using. I actually feel like the ground underneath this whole GMO debate is a kind of a confusion or forgetting or a disconnection from our food generally. So what I like to talk to about is the way that our food system itself, not just the GMO part of it, but the whole food system itself has gotten very disassociated for most people. And I like to have people think about the way the landscape has changed in this country since World War II, when we constructed an entire interstate highway system that now we're familiar with. It's 47,000 miles long. It connects all the major cities in the United States. And that is the construction of all those roads is what allowed us to suburbanize. We were able to build millions and millions of houses on the rings around our big cities. That story we know, but what people sometimes forget is what all those suburbs were built on top of were small farms. And in the last 40 or 50 years, the United States has lost 4 million small family farms, 4 million farms. And what that has done is really changed the landscape in ways that we have not seen really even in the entire global community, this kind of radical transformation of the landscape. All that food production then, of course, moved to the Midwest, where it got industrial in scale and led eventually to the development of these genetically altered crops. That part of the story we're familiar with. But the part that I'm interested in is how much we've become disconnected from our food generally. So we're confused about GMOs, but really what we have lost touch with is food production generally. Very few people have any contact with actual farmers. I like to joke that, this isn't a joke, I like to tell the story that sometimes my students, when I ask them where potatoes grow from, they might say they grow on trees because they've never seen a potato actually growing. That level of disconnection is very unsettling to people when they start to think about it. They walk into a supermarket and they see this great variety of foods, but they have no way of thinking or talking or relating to what they're actually looking at. I think they say there are 47,000 different products in a typical supermarket, and the provenance of any of the ingredients or the individual foods is completely unknowable to most Americans. So the GMO debate is a really rich one, but it also points at much, much more kind of structural problems that we've developed because we've lost touch with this very intimate part of our lives, which is how we feed ourselves.
You can join the conversation, 860-275-7266. I want to take a call. Barry from Brookfield. Barry, go ahead with your question.
Yeah, I had a question regarding the chemicals that are used to weed the fields, which used to be predominantly glyphosate, Roundup, and as weeds became resistant to Roundup, I understand there have been modifications to allow the fields to be weeded with 2,4-D, which was half of the chemical we called Agent Orange, and that came to no good when we used it last time in Vietnam. Glyphosate has been found to be carcinogenic, or at least it's a probable carcinogen upgraded from possible by the World Health Organization just in the past couple of years. We're eating that stuff when we eat genetically modified crops that have been modified to resist those chemicals. How could that be a good thing? That's my question. I mean, I try to avoid it, just like I would avoid secondhand cigarette smoke.
Barry, thank you for your question. Dr. Margaret Smith, do you want to answer Barry's concern? He just said that worried about how those chemicals are then getting into the food. Is that something people should worry about?
Thanks. Yeah, that's a really good question. So I'm going to back up a few steps and, following a little bit on McKay's conversation. Pre-genetically engineered crops, most weeds were controlled by other herbicides than glyphosate because glyphosate or Roundup broadly just kills plants. So I think we can reach back that far and say there were things that were used broadly before glyphosate. With the advent of Roundup-resistant crops, I think one of the things we've done wrong with that technology, and we can argue about many others, but is that people have viewed it as a silver bullet. All of our understanding of how to manage pests comes from integrated pest management, which says you shouldn't keep doing the same thing over and over and over again. Well, the glyphosate-resistant crops were so convenient that the extent of use of glyphosate in agriculture went up dramatically as they were adopted because it was a very simple way to control weeds. There were a few different impacts from that. One, much, much broader use of glyphosate, and second, the completely predictable evolution of resistance. Mm-hmm. When you treat a lot of weeds with a chemical that kills virtually all of them, the only thing leaving seeds for the next generation are the ones that were not killed by it. So very quickly you select the weed population to be resistant. So I think the fruits of that overuse have now come home. The chickens have come home to roost. I'm mixing my metaphors. But that then led to an industrial response, which was to try to develop new sources of crop resistance to herbicides. The 2,4-D that you mentioned in your question is one of those. It has actually not been very widely used because of some notorious problems with it over the last couple of years, and those problems related to drift. 2,4-D is a naturally very volatile chemical. That's part of why it was so destructive when we used it before. And it was sprayed perhaps with a little too much wind, perhaps just it drifts too much, but there were some big problems with adjacent fields being damaged by it. So right now that whole area is regrouping a bit, but you're correct that we really do have extensive use of glyphosate. The data on its carcinogenicity is mixed. So there was a declaration that it was a probable carcinogen. I'll remind you that many other things we all consume regularly are much more highly rated on the carcinogenicity scale, grilled steak, alcohol, and so on. But it was rated as that. Obviously, consuming grilled steak and alcohol has its positive aspects. Consuming residues of glyphosate, perhaps not so much. But this is sprayed early in the crop life cycle, so it's largely broken down before any of it gets to what you would consume as food. So I would argue that you're probably not consuming it. Pre-glyphosate, you had a similar issue where you were perhaps consuming other residues of other herbicides that are generally regarded as even less safe. So I think the concern is a valid one. The concern about the way we use this technology in the agricultural landscape is a tremendously important one. I think it's been unwisely used in some situations. The concern about glyphosate as a carcinogen, I'm not a medical doctor, so I'm sort of watching that debate just like everybody else. But my take on it would be that anything that we use extremely broadly in the landscape has much greater potential to be hazardous just because the level of exposure is so much more regular and at such a higher level.
Can I add something to that?
Yes, McKay, go ahead.
Yeah, I think that's a really important point, and I'd like to maybe say two additional things. One is one of the most obvious environmental consequences of this incredibly vast use of things like glyphosate has been, it's very effective of doing what it's supposed to do, which is to kill weeds, kill not anything that's not a soybean, for example. But one of the things it's been killing very effectively is milkweed, and milkweed, as many people know, is the primary food source for monarch butterflies. So when you see a monarch butterfly population that is now hanging on at about 4% of its historic levels, the relationship between the near extinction of a charismatic species that many people have come to love and the use of chemicals on food sources is a direct connection. This is not abstract. You increase glyphosate, you lose monarchs. So this is one of the unintended consequences of this. And then structurally, I think it's important to remember that what we're really talking about is ways that the industrial agricultural system has itself blown up and become so vast. We're talking about 200 million acres or so of genetically engineered crops, and you add in another 100 million acres of wheat, which at the moment is not GMO, and you're talking about 300 million acres of American land, which if you're like me, and if you've driven across the country a few times, you can drive from Maryland to Colorado and basically see nothing else across the entire American landscape than 3 industrial crops that are being planted on every square inch of our landscape. There's just not an ecologist on the planet that would think that's a good thing. So maybe in a minute we'll get to some of the consequences of this. The genetic engineering part of it is often talked about by scientists as a tool. It's a tool that can be used for this or that, often for really positive, productive things, but in some cases with industrial ag to support a system that is really gone off the rails ecologically and has a whole variety of negative consequences. So all of these things are complex conversations, and it's important for listeners to know you've got a scientist on the line here who is a genetic engineer who is also very aware of things like herbicides. That not all genetic engineering scientists are somehow lumped in with this great evil system. They're all extremely aware of the consequences of what we're all doing. So it's really useful to have all these different perspectives because everybody's contributing something to a very complex and historically fraught system that we're all living in now.
On the phone with us, McKay Jenkins, professor of English, Journalism, and Environmental Humanities at the University of Delaware, author of Food Fight, GMOs and the Future of the American Diet. Also with us from Cornell is Dr. Margaret Smith, professor of plant breeding and genetics, who specializes in corn breeding at Cornell University. You can join our conversation, 860-275-7266. Ben's calling from Wallingford. Ben, go ahead.
Hi. I appreciate what Mr. McCabe just said about the industrial food system because I feel like GMOs are contributing to a host of problems. The development of superweeds, like was mentioned before, and super bugs that are resistant to these pesticides and the overuse of pesticides similar to the overuse of antibiotics. But I think the main problem with GMOs is that they are basically used as a industrial tool for making profit and not to increase yields. I've seen studies that said that organic agriculture without pesticides and GMOs is more productive than GMO crops, and that the GMOs are basically strategies to make things like square tomatoes that can be packed and things that look better in the grocery store but aren't more nutritious. So I just feel like while the science can be very valid, and I don't blame the scientists, this process has been taken over by corporations who don't have the interest of people in heart.
Ben, thank you for your question. I want to ask Margaret to respond to some of the concerns Ben raised.
Yeah, thank you. That's a complicated question with a lot of dimensions to it. So I first want to just say, I really enjoyed McKay's comments on our food system because I think that is really the heart of what this questioner is asking. If you look, one of my colleagues, Charlie Brummer, who worked at Iowa as a forage breeder, there's an endangered species because there are not many forages grown in Iowa, did a nice comparison where he looked at aerial images from the 1950s and aerial images currently. And you went from a very diverse agricultural system with lots of different small patches of crops to basically a situation where half the state is planted to corn and half the state is planted to soybeans. That degree of uniformity is bound to be ecologically problematic. I will say in response to the specific question just a few things. One is that Some of the genetically engineered crops have clearly been used to reduce the amount of pesticides that are sprayed. So cotton, for example, is one of the crops that uses a lot of insecticides if you want to produce it. But if you use genetically engineered cotton that resists those insects, the level of insecticide use has gone down dramatically. Those insecticides can have a lot of non-target effects, so I would say that's a net positive. Are these things being developed and used by the large-scale agricultural industry? They certainly are. Those are the people who have the research and development pockets to be able to do this work. So I think that's where it's happening. Is it feeding into an agricultural system that is too large-scale and uniform? I tend to agree with that point of view. We're blessed here in the Northeast that we don't have the large, flat, excellent soils and landscapes to be able to have that kind of an agricultural system here. So ours remains somewhat more diverse, which I think is a good thing. Genetic engineering is just one of the many tools. It has not necessarily led to higher yields, but it has made for more stable yields of the major crops in which it has been used, because the traits built in are defensive ones: defense against insects, defense against weed competition, defense against drought in some cases. So I think it can be used for some things that are good, but right now it's happening in the context of a food system and an agricultural system that has many of the potential problems going forward that McKay has talked about.
Now, Ben, when Ben called, he touched on the mistrust that Americans have when they, again, see this large ag system controlled by companies like Monsanto, DuPont, and Dow. Obviously profit-driven, the fact that these farmers have to buy these new seeds every year. But can we talk a little bit more before you have to go, Margaret, about the distrust that people have with the science around GMOs and how we can get past that? Is it that certain scientists who work for these big companies, they wonder how much clout they have in the food policy that's negotiated down in Washington?
Yeah, that's a tough question. So I'm a non-genetic engineer, but a scientist, and so I talk about science and facts. I think the evidence, if you look at the social science literature about what convinces people and what makes people think about changing their minds, which is something we all do very, very, very infrequently, facts are not what change people's minds. Stories, relationships, talking to people who they have something in common with and might trust are the way people stop and rethink their views. I think this is part of what makes this debate so challenging. I would say the science is pretty clear on food safety. The environmental science is really questions that are of much larger agricultural systems nature. The people talking in this debate, if you just look at the genetically engineered crops piece of the conversation, are people who on both sides have vested interests. There are industrial players who are trying to sell a product, so they have an economic interest. And there are opponents and activists who are from organizations that need a cause around which to raise money, so they also have a vested interest. So it's very hard to find sources of information that don't come with some sort of a vested interest. I think that's part of the complication in talking about this issue.
Dr. Margaret Smith, again, is professor of plant breeding and genetics who specializes in corn breeding at Cornell University School of Agriculture and Life Sciences. Thank you for joining us today. We appreciate it.
Thank you so much. It's been a pleasure, and thanks for having me.
McKay Jenkins is going to stay with us as we continue this conversation. Now, after the break, how can Americans promote and encourage sustainable farming? One way, support local farmers. We're going to hear more after the break. This is Where We Live. I'm Lucy Nalpathanchel. Author McKay Jenkins is with us by phone as we talk about genetically modified organisms, or GMOs. He's the author of the book Food Fight, GMOs and the Future of the American Diet. I want to take a listener call. John is calling from New Haven. John, go ahead.
Yes, I had two comments. One, in practice, it's being used to generate monoculture. For decades, Monsanto has been planting GMO crops next to traditionally planted crops. And because the government has allowed the technology to be patented, if a single plant in the regular farmer's crop is contaminated with the pollen from another plant that's GMO, it's an IP, intellectual property violation, and their their fields have to be burned. And this represents a strategic threat to the United States because recently Monsanto was sold to a German company. Now, if Germany sells the patents or if it sells itself to say Russia or China, they can hold the U.S. food source hostage because farmers will be forced to buy the GMO seeds, and if they control the seeds, they control the distribution.
John, thank you for your call. McKay, do you want to address what John was talking about in terms of GMOs, causing a big problem, monoculture, but that's also something that predated genetically engineered plants?
Well, his comment is actually perfectly emblematic of the suspicion and even, I would say, paranoia that people have when they start thinking about this. Like, whether you go as far as to think that the American food supply could be controlled by Russians, it's actually not, in theory, inconceivable, because right now our food system is controlled not by Russia but by a very few companies. They literally own the legal patent on biological phenomena. They own the patents on genes. Now, whether you are worried about Russia or whether you're worried about Monsanto, the fact is that these are already controlled by very centralized entities. That is a problem. Ecologically, as we mentioned before, it's a problem because we've got, as I said, 300 million acres that are being planted basically to 3 crops. In terms of our diet, we have lost something like 97% of the diversity of crops that we used to enjoy. We're eating 10% of the kinds of apples that we used to enjoy. It is really an astonishing expanse of this monoculture farming across the landscape, and it has consequences that are both ecological and sociological. So really, it takes a long time to get at all of this stuff, but it's all it's colossal in scale and invisible at the same time, which I find to be very intriguing as a journalist, because it's right there every day, 3 meals a day. You're sitting there looking at a plate with stuff on it, and you can't figure out where it came from. You may not even care to. You may not even think about it. But when you scale that up to the number of people that are eating this way, it has colossal consequences. And now that the entire continent is planted with these crops, we are now pushing into South America. So these companies are now selling their seeds and converting in South America things like rainforest to monoculture industrial crops so that they can feed more beef, so that we can send more hamburgers out to the rest of the world. The whole world, weirdly and sadly, thinks that it needs to eat like Americans, and this is a food system that doesn't even work for us, to say the least, and now it is starting to spread globally. And what we don't want to do, of course, is to spread, what do they say in the United States, that 1 out of 3 white babies will eventually become diabetic, and 1 out of 2 black babies will become diabetic, because we are now all eating this food. So, once you scale this up to the way it actually functions with our body, whether GMOs themselves are somehow dangerous, what they are certainly doing is contributing to an industrial food system that is patently dangerous, not because of genetics, but because of the high-calorie, low-nutrition food that we're all addicted to now. So there's that part of it. There's the corporate control of it. There is the ecological, the absolute depletion of the health of our soil, the health of our water supplies. All of these things are basically built on top of this system. Industrial agriculture is also one of the primary contributors to climate change. It's a very intensely fossil fuel-dependent industry. So it sounds like we're going to talk about local food. To me, local food is the solution to virtually every one of these problems. It takes the power away from corporations. It diversifies crops. It improves the soil. It reduces carbon use. It actually plants carbon in the soil, because farmers are much better at getting soil out of the atmosphere and into their soil. It preserves water supplies. It improves the nutritional value of the food. It improves local economies. There's really a lot to say about spending every dollar you can with local food production, and as opposed to this corporate, distant, abstract industrial food production. These are two really radically different things.
Let's get to a Connecticut farmer on the phone with us now, Roger Phillips, a farmer at Sub Edge Farm in Farmington, Connecticut. Roger, welcome to the show.
Thank you so much, Lucy.
So we're hearing McKay break down all the reasons why communities should support sustainable farming, support local farms such as SubEdge. Why did you get into traditional farming, and what are you hearing from your customers today about the kinds of food they want?
Well, we got into growing our own food because we wanted to grow something healthy for our children ourselves, and we just got really jazzed about it. We're really excited about learning how to grow new things all the time, and we love to share that with people too. And I think our customers see that. Our customers are keyed into a lot of these issues that we've been talking about today. They're interested in all of those ideas about not just healthy eating, but local economy as well. Our farm employs about 10 people. We're all out working in the fields. It feeds our family, it feeds our neighbors, and I really do believe that small farms like ours can feed the country, but we just need to support them so they can make it. I mean, the farms are out there in Connecticut, and they just need more support.
Roger, what do you grow on your farm? Again, we heard about the grip that monoculture has, especially in the Midwest, but what are some of the crops that you're growing and the challenges of providing that variety? Have you encountered them?
Sure. Well, we are definitely not a monoculture. We're a polyculture, and we love that because diversity helps the farm on so many different levels. From an economic standpoint, if we have a catastrophic weather event, for instance, that could destroy some crops, we have something else to fall back on. But also properly rotating crops is something that we do. So we're always moving different families and species of plants around the different areas of the farm so they don't have that disease and pest pressure buildup. So there's a lot of management involved. There's to grow 100 different kinds of fruits, vegetables, flowers, culinary herbs that we're doing, as well as raising some livestock. There's a lot of different steps along the way and challenges in just knowing the timing and the planting schedules and the harvest schedules to be able to create a really quality product that we can deliver to people.
Roger Phillips is a farmer at SubEdge Farm in Farmington. Roger, thanks for joining us for just a little bit. We appreciate it.
Yeah, you bet.
Now, McKay, I wanted to go back to you. We just have a couple of minutes left, but we wanted to find out a little bit more about, again, there's a lot of distrust surrounding genetically modified crops. Again, these ag chem companies that have a firm hold on our industrial food system here in this country. But what about a lot of the research that's being done, even by nonprofits, to work on genetically modified crops that are helping other parts of the world, including this golden rice debate? I don't know if we're going to have that much time to talk about it, but it's important to bring up, I think.
Sure. I think this is really important for people to understand. As we heard early in the program, people tend to be almost tribal in their feelings about this. So you're a liberal, you're anti-GMO. If you're conservative, you're pro, and you don't want to think any further than that. And that's actually really a poor way to think about it, because genetic engineering is, in fact, just a scientific tool, an engineering tool, and there are ways to use genetic engineering to improve things like nutritional profile of things like rice, which has no, for example, beta-carotene in it until you genetically alter it. If you genetically alter it, you can serve rice with beta-carotene in it to cultures that have very little access to beta-carotene, and suddenly kids aren't dying from vitamin A deficiency. You can create plants that are resistant to drought, that sort of thing. That's really helpful. That is all being done by university researchers and nonprofits. It's not the problem. The problem is the use of this technology by these enormous companies, which one thing we didn't talk about and should just briefly mention is they have absolute stranglehold on federal farm policy. So you talk about billions and billions of dollars being pumped to these companies by the government that they control, and that's why you're not seeing massive federal support for things like small-scale farming or organic farming, is because the conventional big industrial companies have their hands around the neck of the federal farm policy, and that really is the deepest issue here of all. It's political control by these big companies.
McKay Jenkins, author and journalist, his book Food Fight: GMOs and the Future of the American Diet. Unfortunately, we've run out of time, but we thank you for joining us today.
Thanks a lot.
Carmen Baskoff produced today's show. Special thanks to Lydia Brown and Jean Amatruda. Again, you can learn more about the show at wnpr.org/wherewelive. I'm Lucy Nalpathanchel. Thanks for listening.